Hello my friends, see you again in this amazing game development secrets channel. Today I'm going to tell you something about enemy intelligence. Before that, let me present you some improvements made on my game. As you can see, there are some minor graphical improvements, and also you can take ammo now. For example, like for this shotgun, this is ammo for it, and we can take it, and ammo is increased. Then there is a new kind of zombie which is faster than the previous one and harder to kill. But let's speak about our today's subject. Some characters or vehicles are controlled by you as a player, and others are controlled by a computer. They are called non-player characters or NPCs. So that's why there are two types of controllers in Unreal: player controller and AI controller. Player controller, of course, represents keyboard, mouse, joystick or other devices which you can use to control your character. And AI controller, on the other hand, gives other characters their ability to make decisions independently of humans. Let's speak for a while about player controller in more depth and then about AI controller. As an example of player controller, there can be vehicle with no controller associated, just waiting to be controlled or possessed by a player. So when you enter the vehicle, player controller, I mean keyboard and mouse for example, starts controlling it, and so you are able to drive that vehicle until you leave it and player controller is disassociated. Okay, and what about AI controller? The most common and supported method implementing intelligence in Unreal is a behavior tree. I am going to show you one example of it. So let's go here and open behavior tree. As you can see, this is a behavior tree I have implemented in my game. It's a simple one right now, but it can become more complex later. As you can see, it's a format of a tree which executes its nodes from left to right and top to bottom order. There are also small numbers indicating the order. Leaves, I mean the nodes without any outgoing arrows, represents some tasks as, for example, move to location, wait or attack. And others, like this one, just make sure that the tasks are executed at the right time. There are two most important non-leaf types of nodes, and those are sequence, like this one, and selector, like this one. Selector executes its child nodes from left to right, of course, until it finds a successful one. Sequence, on the other hand, executes its child nodes until it finds unsuccessful one. You can imagine that as a very common logical operators and or. The result of selector again fails when there is no successful node found, so all are unsuccessful, and sequence fails when there is one unsuccessful node found, so at least one is unsuccessful. Let's end it here because we are going into too much details. So please like, subscribe and share it. See you next time.